Good morning. We were discussing vector calculus and we have seen how to differentiate vectors using an operator called del. So using the vector operator del, which is equal to dou by dou x, I cap plus dou by dou y, j cap plus dou by dou z, k cap. How we can differentiate scalars and vectors. First, we saw how to find the gradient of a scalar quantity, which is called grad. Suppose phi is a vector quantity, a scalar quantity, then grad phi is represented by del phi. And we found how to find grad phi, and when we take grad phi, we will get a vector. So this is a way to convert a scalar quantity to a vector quantity. Then we found divergence. Divergence of a vector. Divergence of a vector A, which is represented as del dot A. So we take dot product with this del operator acting on a vector A, and what we get will be a scalar quantity. So this is a vector quantity and this will be a scalar quantity. These are the two things which we have found, and we also learned that if del dot A is equal to 0 or the divergence is 0, we call that A as solenoidal. A vector is said to be solenoidal if its divergence or dot product with this del operator is 0. If it is called a solenoidal vector. Now today we will see how to find the cross product between the del operator, vector operator, and a vector, and we call that curl of a vector. What is meant by curl? Curl means rotating something, right? So curl of a vector, curl of a vector, curl of a vector means taking the cross product with the operator, vector operator del. So curl of a vector means del cross any vector A. Suppose we have a vector A represented by AXI plus AYJ plus AZK. And del, as you know, is given by del is equal to dou by dou x I cap plus dou by dou y j cap plus dou by dou z k cap. Now when you take the cross product between these two, how can we find the cross product? Del cross A is equal to, you have to take the determinant. Take I, j, k as the first row, then you have to take the coefficients of I, j, k for del operator as the second row. Dou by dou x, dou by dou y, and dou by dou z. And you have to take the coefficients ax, ay, and az as the third row. Ax, ay, az. Now, remember that del cross A is defined as the curl of a vector. What about A cross del? Can there be A cross del? No. A cross del, a vector A cross del is not possible. It's not possible because del has meaning only if it acts upon a vector, only if the vector comes after del. Now, what will be the direction of the curl of a vector? When we take the cross product of two vectors, what will be the direction of the result? Suppose you have a vector A and a vector B. A cross B is equal to C. Now, what will be the direction of C? Remember how to find the direction of C? You have to take your right hand. Yes, Hasina, tell.
Right hand screw rule.
Yes, right hand screw rule. So what about C? The vector C will be, will it be in the same plane as A cross B? A and B? No. Vector C
No.
will be perpendicular to both A and B. So similarly, when we take the curl of vector A, the curl of A will be perpendicular to the vector A. So when you are taking the curl of a vector, you are finding its difference with respect to position, and also you are rotating it through 90 degree, because the curl of a vector is perpendicular to vector A. So the curl of the vector will give you a vector which is making 90 degree with vector A. So you are in fact rotating the vector as well. So you are finding the rate of change of the vector, and also you are rotating it through 90 degree. Now what if a vector del cross A is equal to 0? If for any vector A, del cross A equal to 0 means you cannot rotate it. So when you are taking curl of A, it means you are rotating the vector, because the result curl of A will be perpendicular to A. So if del cross A is equal to 0, you can call vector A is irrotational. You cannot rotate that vector. So if it turns out that del cross A is equal to 0, it implies that A is irrotational. So how to find the curl of a vector? You can find the curl of a vector by taking del cross A, that is the determinant ijk, dou by dou x, dou by dou y, dou by dou z, ax, ay, az. You know how to write the determinant, expanded form, right? How to find it? This is equal to vector I times dou by dou y of az. So dou by dou y of az minus this one, dou by dou z of ay. Dou by dou z of ay minus j cap. You have to neglect this row and this column, and then you will get these and this. So dou by dou x of az minus dou by dou z of ax. Dou by dou z of ax. And don't forget to take alternate negative sign. Now plus k cap times, you have to neglect these two and you will get this. So dou by dou x of ay, dou by dou x of ay minus dou by dou y of ax. Dou by dou y of ax. So this is how you can find the curl of a vector. Now we will do some problems so that we can find the gradient, divergent and curl of different vectors, and also how we can check whether a vector is solenoidal or whether a vector is irrotational. So we will do some numerical problems given in the text related to vector calculus. Is this clear to you, how to find the curl of a vector?
Yeah, teacher.
What will you call the vector if the curl is 0? What will you call the vector if the curl is 0? You call it irrotational. So in a question, if you are asked to check whether a vector is rotational or irrotational, what you have to do is find the curl of the vector. If it is 0, you can tell that that vector is irrotational. So let us see some problems. Let us solve some problems that will give you better understanding. So let me consider the first problem. In your textbook, it is problem number 214. And it says that there is a scalar function phi, which is a function of x, y, and z, that is equal to 3xy square z cube minus 4xy, and find grad phi at a point. So find grad. What is meant by gradient? Grad phi at They have given a point 2, -1, 1. So this is the question. You have to find gradient of the scalar function phi. So remember how to find grad phi. Grad phi means del phi. So let us see how to find. Del means dou by dou x I plus dou by dou y j plus dou by dou z k. And you have to multiply this, or the operator should act upon the scalar quantity 3xy square z square minus 4xy. So let us do that. First, this is equal to dou by dou x of this quantity. Dou by dou x of 3xy square z square minus 4xy into I cap, plus dou by dou y of 3xy square z square minus 4xy into j cap, plus dou by dou z of 3xy square z square minus 4xy, okay, into k cap. Now this is partial differentiation. So when we are doing partial differentiation with respect to x, we can consider y and z as constants. So here it is 3x. So only x to the power 1. So this will be dx by dx is equal to 1. So dou by dou x of x will be 1. So this will be equal to this term will be 3y square z square. And here again x is there. Dou by dou x is 1. So dou x by dou x is 1. So it will be minus 4y into I cap, plus dou by dou y of this term. Here you have y square. X and z can be considered as a constant. So dou by dou y of y square will be 2y. And 2 gets multiplied with 3. So you have 6xyz square minus, here x can be considered constant. So dou by dou y of 4xy will be just 4x times j cap, plus dou by dou z of this quantity. Here x and y can be considered constant. We are differentiating only with respect to z. So we will get here 3xy square. Dou by dou z of z square is 2z. 2 gets multiplied with 3. So you will get it as 6xy square z minus, and is there anything related to z? No. So this is a constant with respect to z. So you can consider this dou by dou z of this quantity will be 0. So I am not writing that. So plus this quantity k cap. So this is grad phi, and grad phi at 2 minus 1 1, which means instead of x you have to put 2, instead of y you have to put minus 1, and instead of z you have to put 1. So this will be equal to 3, y is minus 1. Minus 1 square is 1 times 1 square 1 minus 4 times minus 1 into I cap plus 6 times x is 2 times y is minus 1 times y square z square 1 square 1 minus 4 times 2 again j cap plus 6 times x is 2 times y square minus 1 square is 1 times 1 k cap. So you can do here 3 plus 4 because minus times minus 4. So 3 plus 4 is 7 I cap. 6 times 2 is 12 minus 12 minus 12 minus 8 because 4 times 2 is 8. So minus 12 minus 8 will give you minus 20 j cap, and here you have 6 times 2 12. So plus 12 k cap. Is this clear how to do this problem? Is this clear to you?
Yes, teacher.
Okay, so let us try another one. So you found how it will come for as a problem in vector calculus. You may be asked to find the gradient of a scalar quantity at a point. At a point means after finding the gradient, you just have to substitute the values for x, y, and z. Okay, let me consider another one. Here, this is question 2.15. You have a vector A is equal to 3x square z times I cap plus x, y, z square j cap minus x cube y square z k cap. So this vector is given. Find, and you have to find del dot A. Del dot A means divergence, and del cross A. Del cross A means curl. Sorry, cross. Cross A means curl, and both at a point 1, -1, 1. So here you have to find both divergence and curl of this vector and at a particular point. So you can first find the divergence del dot A. So del dot A is equal to, you know, it is dou by dou x I cap plus dou by dou y j cap plus dou by dou z k cap dot this vector A, that is 3x square z I cap plus x y z square j cap minus x cube y square z k cap. So when I take the dot product, I dot I is 0. Sorry, I dot I is 1. I dot j is 0, I dot k is 0. So I have to consider only I dot I, which is 1. So this will be multiplied only with this. So this is equal to dou by dou x of 3x square z plus dou by dou y of, because j dot j is 1, all other dot products j dot I and j dot k are 0. So I have to consider only this. So dou by dou y of x, y, z square plus dou by dou z of, I have here minus. So I will make this as minus and x cube y square z. So this is equal to, when I take the partial differentiation, I can consider z constant. So dou by dou x of x square will be 2x. 2 gets multiplied with 3. So I get 6xz plus. Now here y is a, I can consider only y. Consider x and z as constant, and dou y by dou y will be 1. So x z square minus, here z, other two can be considered constant, and dou z by dou z will be 1. So this is x cube y square. Now at this. So this is the divergence del dot A we have found, and del dot A at 1 minus 1, 1 is equal to, instead of x, y, z, you have to substitute this. So this is equal to 6 times x is 1, z is 1. So it will be 6 plus x z square. X is 1, z is 1. So 1 square will be 1. So it will be again 1 minus x cube is 1, y square, y is minus 1. So square will be 1. So minus 1, this is equal to 6. Is this clear to you? Is this clear to you?
Yeah, yeah, teacher.
So how to find the divergence of a vector at a particular point? First find the dot product, that is the divergent, and put the xyz value, you will get that. Now let's do the curl also. So they have asked to find both divergence and curl. So uh, see here, for divergence, you got a number, which means it's a scalar quantity. So when you find del dot A, you will find it is a scalar quantity. Now, let us find what is del cross A. So when you do del cross A, you have to take the determinant I, J, K, and dou by dou X, dou by dou Y, dou by dou Z. And you have the, instead of A, this quantity. So I have the X, 3xz square and xyz square and z cube, x square, x cube, there is minus x cube, y square, z. So when I take the determinant, it will be I cap times dou by dou x, so sorry, dou by dou y of this quantity. Dou by dou y of minus x cube y square z minus dou by dou z of x y z square. X y z square. Okay. So this is for I, and minus j cap times, I have to eliminate this row and this column. So I will take dou by dou x of, excuse me. So j cap times, I have to consider dou by dou x of this quantity, dou by dou z of this quantity. So dou by dou x of minus x cube y square z minus dou by, okay, j I am doing, right? So this and this. So dou by dou z of 3x square, 3x z square plus k cap. K cap times, we have to take dou by dou x of this quantity. Dou by dou x of x, y, z square minus dou by dou y of 3x square, 3x z square. So you will get as equal to, you can tell me the answers. Why are you silent? Are you focusing on this? Is it visible to you what is written on the whiteboard?
Yeah, teacher.
Yes.
It's visible. So please tell me what will be dou by dou y of this. Minus sign is there. I times dou by dou y of y square will be 2y. So 2y, so minus 2x cube y z. Are you getting the concept? Are you just silent because you understand, or you don't understand? Why are you silent? If you
We are getting
understand, please tell me the. Okay, what is dou by dou z of this quantity? X, y, z square. Dou by dou z.
2z square.
2. If I take 2, it will be z, not z square.
Sorry.
2z, right? And xy is already there. So 2 x, y, z. Okay? Minus j. Now you can tell. Dou by dou x of this.
2xy.
This is x cube, y square, z. You are differentiating with respect to x.
3x.
Yeah, minus 3x X cube is
2y.
x square minus 3x square. It will be y square z minus, okay, now try this. Dou by dou z of 3x z square.
2z.
Yes, 2z. So 3x into 2z. Because 3x is also there, right? What is 3x into 2z? 3 times 2.
6.
So it will be 6xz plus k cap times dou by dou x of this one, xyz square. What is dou by dou x of xyz square?
2y z square.
Yz square. Dou x by dou x will be 1. So just yz square minus. Is there any quantity containing y here? Is there y in this term? No, it's 3x square, right? So dou by dou y of this will be considered as a constant. So dou by dou y of a constant should be 0. So this is how it is. So this is equal to, now you can put the values 1 minus 1 and 1 for x, y and z. So I have I cap times minus 2 into 1 cube is 1 into minus 1. Minus 2 into minus 1 is 2 into 1. So I have here just 2 minus 2 into 1, 2 into minus 1. So this will become plus 2 into 1. So plus 2 minus j cap times minus 3. X square means 1 square. Y square means minus 1 square, which is 1 into 1. So this 3 becomes into 1. So just minus 3. Then I have minus 6. X is 1, Z is 1. So 1 into 1. So no change like that. Plus K. Y is minus 1. Z is 1. So minus 1 into 1 square. So it will be minus 1 and minus 0, no need. So this is equal to 2 plus 2, 4. For I, minus 3 minus 6 is minus 9. Minus 9 times minus. So it will be plus 9j minus k. So this is how we can find del cross A at 1 minus 1. Is this clear to you?
Yes, teacher.
Yes, teacher.
You have to solve by yourself. Now I understand that when we take the partial differentiation, you have confusion. So I will give you a problem which you can do by yourself at home. Otherwise, you won't be able to solve this. If you don't have confusion, you have to tell me when you differentiate, when you do the partial differentiation, you have to tell me the answers. Okay? We will consider one more problem where you should tell me when it comes to the partial differentiation. So let me consider problem. Okay, 2, 1, 6. A position vector R is given as equal to I cos 5t plus j sine 5t. Okay, and show that vector field R is solenoidal. So show that R is solenoidal. Show that R is solenoidal. How can we show that R is a solenoidal? What should I find to show that R is solenoidal? What should I do with R? Should I take the gradient, divergence, or curl? They have told to show it is solenoidal. So what should I do? Gradient, divergence, or curl? I have to take divergence. That is del dot R. If del dot R is equal to 0, I can say that R is solenoidal. So let us see how to find del dot R. Del dot R means dou by dou x I plus dou by dou y j plus dou by dou z k dot this one I cos phi t plus j sin phi t. So here you have trigonometric functions cos and sin. What is d by dx of sin theta? What is d by dx of sin theta? That is equal to cos theta. And what is d by dx of sin a theta, where a is a constant? It's a cos a theta. You need to know these formulas. And what is d by d? Okay, not dx, sorry, d theta. What is d by d theta of cos theta? You have to tell me. What is d by d theta of cos theta?
Minus sin theta.
Yes, minus sin theta. And what is d by d theta of cos a theta, where a is a constant?
Minus sin a theta.
Minus a into sin a theta. Okay, there will be a minus sign if you are differentiating cos, and if there is a constant with the angle, see, phi t. Write that, right? So you have to consider that. So this is the formula. Let us see now. Here, you won't have to use those formulas, especially in this. This is equal to dou by dou x of the I quantity here is cos phi t, right? Cos phi t. It's dot product. So no need to take I. I dot I is 1 and I dot j is 0. So no need to consider. Then plus dou by dou y of sin phi t equal to, for dou by dou z, there is no quantity with k cap there. So nothing in the z direction for r. So no need to consider. Only two terms we have here. Now what will be dou by dou x of cos phi t? Can you tell me?
Minus 5 sin 5t.
Yeah. If it was x, instead of t, if it was x, you can tell dou by dou x of cos 5x is equal to minus 5 sin 5x. But it's not x, it's t. I told you when we are taking partial differentiation with respect to x, other than x, whatever is there can be considered as a constant. So t is a constant in this case. So you can consider this whole quantity as constant. There is nothing related to the variable x here. So this quantity will be 0 because this is dou by dou x of something which doesn't contain x. This is not a function of x. It's a function of t, time only, not position. So this will be equal to 0. Plus, here again the same rule applies. There is nothing related to y. This is not a function of y. And since this is partial differentiation, time t can be considered constant, we have to differentiate only with respect to 1. So this also will be a 0. So the result is 0, which means R is solenoid. Therefore, we have shown that R is solenoid. Is it clear?
Yeah, teacher.
Okay, partial differentiation actually makes our work simple. We don't have to consider the dependence of time on position. No need. We just can consider anything other than with respect to which we are differentiating as just constant.